Welcome to the Sizer online tutorial for the US edition. Following the video where we demonstrated how to make a model of a two-story structure inside concept mode, in this video we will go through the results once the loads have been applied. By running the design, a result sheet similar to this one will appear. First, the company and project information that you have entered in their respective section in the settings are shown here. Sizer separates results by group, and groups are further separated by their level. As you can see, suggested sections are generated for each group of element that was left with unknown parameters. In our example, since most of the dimension values were left as unknowns, Sizer generated dimensions that would withstand the loads according to the member's type, material, and grade that we have defined. If the group details are specified without leaving any unknowns, the designed member would appear as is. Next, in the critical members and design criteria section, members are also separated by their group. For each group, you will see which member was critical to the design of the group, followed by its critical criterion and the ratio of the analysis and design values. The ratios should be less than 1.0 in order for the sections to be adequate. In the event where the software is not able to render details of a section left unknown that would resist the applied load based on the other information entered, no section found would appear. Under all of this information is the design note. Here you will find design assumptions and considerations upon which the design result sheet is based on. By going in the View tab in the top toolbar, more information is accessible, such as results by member, materials list, and reactions at base. Here again, results by member is separated by the levels of the structure. Every member designed in concept mode, even those designed by the program when unknowns are left, is displayed in this page. In fact, beside the name of the members, you will find the cross-section dimensions that were generated by Sizer and the span. The cross-section dimensions are based on the loading and the member details that we have defined in the previous video, where the cross-sections are the most efficient to withstand the loads applied. In the following columns, the tabulated values consist of the design ratios for positive and negative bending moments, the shear and axial force, the deflection, as well as the fire resistance criteria. Equally important, the last column shows the most critical design criterion acting upon the member, which is the highest value among the cases we have just mentioned. Now, let's take a look at the materials list section. The members are separated by their respective group, either beam, column, joist, or wall. Beside the name of the members is listed the type, species, grade, and dimension of the member generated that the software recommends to use. For the beam and column group, information on the length or height respectively, number of plies, the number of pieces, and the total length required for each material is presented. As for the joist and wall groups, beside the combinations of materials suggested and the name of the element, information regarding the maximum length and the number of pieces required for that length is displayed. Next to that, values on the total length and surface area are shown. The total area is presented at the bottom of each group type. The information provided in this view can be used to create a preliminary list for costing the required materials for a project. Finally, the reactions at base view illustrates the loads each column receives, in this case the 6 columns designed on the first floor. In this example, the reactions at the base in our structure consists of dead, live, and snow loads. Keep in mind that concept mode is just a preliminary design tool because of these assumptions, as explained in video 6.1. Even though the design results generated in concept mode give a good first idea of the section sizes and layout, a more accurate design needs to be performed by transferring members into beam mode or column mode. For the purpose of this example, we will transfer the center beam B2 from the first floor into beam mode. To do this, you first have to select the beam from beam view, and then you can set the mode as beam mode. As you can see, the information entered in concept mode has also been transferred in beam mode. Only now, it is possible to design for bearing and notch if notches are intended. Since the beam is rested on column C2 and C5, we will define the bearing support with the bearing length consistent with the column size determined in the concept mode, which is 6 inches. Applying this on all supports and leaving other inputs as there were inside concept mode, a wide selection of sections recommended by Sizer is generated. Before choosing a section, the list of suggested sections that passed the design check is available along with the bending ratio, shear ratio, and other useful information. Detailed information of the design check calculation sheet is also provided once a section has been selected. The design check page includes the loads, the reactions data, as well as details on the shear, bending, and deflection of the chosen member. We will now jump to the analysis results section. First, in the analysis results, you will find the type of load, distribution, if there is pattern loading, as well as the location and magnitude of the loads. The second table displays the different load combinations used to determine the critical load case and the pattern of the live load. By scrolling down a bit, magnitudes of both the shear and bending forces are found next to each of the load cases defined in the previous table, as well as the span bending. Information on the vertical reactions as well as the duration of load factor for each load combination are found throughout the rest of the table. Finally, the analysis diagram displays the reaction, shear, bending, and total deflection diagrams for the beam that is being designed. The reaction diagram shows the critical uplift load and the bearing reactions at the supports. The shear and bending diagrams show the locations of the maximum shear and bending moment, respectively, both positive and negative values. In addition to this, the load combination resulting in the forces is also displayed. In the last diagram, deflections at various points are shown, with the maximum deflection illustrated with the red dot.